Okay, first, same way with the current source and the voltage source. So there are the two kinds of source. One is the battery source. So current source and voltage source here. The voltage source are normally the battery source. The voltage source are battery source. So battery source is like this. The voltage source are battery source. Battery source you can see that this is for battery. So all the power supply you see that this is a DC power supply. Those are the voltage source. In the practical room you see the DC power supply. Those are DC power supply. This one is the DC power supply voltage source. And this one is the AC supply. This is voltage source. Those are voltage source. So voltage source can provide the voltage to the circuit. Another one will be the current source. Current source are normally the transistors are the current source. So current source is a transistor. The transistors are, you can see the transistor on the diagram here. So here you see the transistor. So this is normally I draw the transistor. That way it is like this. So base, emitter and the collector. Transistor you can see that pin like this. The 3 pin. So this is a transistor. So we can draw a diagram. That will be like this. So this will be base and the collector and the emitter. So this is a transistor. So the voltage source are equivalent circuit. This is the voltage source are equivalent circuit. So this is for the plus or minus. And current source equivalent circuit you can draw. So this is the current source equivalent circuit. So this is the voltage source and the current source are equivalent circuit. So we solve the one problem. This one will be current is given 10 milliampere. Current is flowing into the R1 is 20 kilo ohm. So we have to find the voltage source Vs. So to find the voltage, the current multiplied resistance you call the voltage. So this is the we can calculate. Vs is equal to I into R1. So that way I is equal to the 10 milliampere multiply 20 kilo ohm. So milliampere is 10 into 10 power minus 3. 20 kilo ohm is 20 to 10 power 3. So this is the 10 power minus 3 so we can say. So that way 200 volt. So because of this one you can now convert the voltage. So this one will be like this. So this will be the 200 volt. So this is for the if you find the current and resistance, you can alternatively find the voltage. So we have to find the V1, V2 and Vs for the given circuit. So the current is 5 ampere. The 5 ampere current flowing through the R1 plus 2 ohm. So voltage is equal to I multiplied R. So V1 is equal to the I 5 ampere multiplied R1 2 ohm. And similarly V2, the voltage is equal to I multiplied R. So current is 5 ampere, resistance is 3 ohm. So then you can calculate the V2. So we use the formula V is voltage is equal to I multiplied R, causing the ohm law. So then we can calculate V1 is equal to the I multiplied R1. So I 5 ampere multiplied R1 is 2. So this is the 10 volt. And V2 is equal to I multiplied R2. So current will be the 5 ampere, resistance will be 3 ohm. So this is the 15 volt. Vs is the combination of the V1 and V2. So Vs you can calculate V1 plus V2. So V1 is 10 volt plus V2 15. So you call it 25 volt. So this is for the we can calculate V1, V2 and the Vs for the given circuit. Now we use a potential divider and the current divider. So this means when the two resistors are connected across the supply. So resistor R1 and resistor R2. So for the supplying V. So this is the resistor R1 voltage is a V1. Resistor R2 voltage is V2. So we can calculate this out V1. So the formula is V1 equal to V multiply R1 by R1 plus R2. And similarly, V2 you can also calculate. V2 is equal to V multiply R2 by R1 plus R2. This is we call it a potential divider theorem. This is the potential divider theorem. So this is the potential divider theorem. So V1 is going to be multiplied by R1 by R1 plus R2. V2 is going to be multiplied by R2 by R1 plus R2. This is the potential divider theorem. Another one is that we also utilize the current divider theorem. So this is the current I. The flowing here. So this is resistor R1. This is the R2. So the current flows with resistor I1, and this one will be the I2. So to the current I. So you can also calculate the current I1. I1 you can calculate. The formula I1 is that you use it to the current I multiply with R2 divided by R1 plus R2. And also I2 you can calculate I multiply R1 divided by R1 plus R2. So this is for the current divider theorem. This theorem we call it current divider theorem. So we use the potential divider theorem, current divider theorem. If you know the supply voltage, you know the two resistors, you will be able to find the voltage across the resistor. And similarly, if you know the supply current and the two resistors, you will be able to find the current in the individual resistor branch. So we use the potential divider and the current divider theorem. So we need to find the voltage V1. And also, you also need to find the current is given, 6 ampere current is given. You need to find the current I1. Current I1 and to the supply voltage Vs. So you can see that the current is at 6 ampere. So 6 ampere flow into the R120. So to find the current I1, what you have to do is to the current 6 ampere multiply R2 divided by R1 plus R2. So by this way you can find the current I1. So I1 you can calculate. The formula is I multiply R2 by R1 plus R2. So the I is to the current given as 6 ampere. R2 is 1 ohm. R1 plus R2 is 2 plus 1. So that will be 6 divided by 3. So you got the 2 ampere. I1 is equal to 2 ampere. After you got the I1 2 ampere, the I1 multiply R1, you got the V1. So V1 is equal to I1 multiply R1. So I1 is 2, R1 is 2. So you got the 4 volt. So V1 is 4 volt. Okay, then you got the storage diagram. Okay. So this is for the supply voltage Vs. This is ground. And this one voltage is already the 4 volt. And this ground is 20 volt. So when the current flow here, ever flowing point ever positive, flow point ever negative. This is the every circuit. When the current flow into a resistor, flow in ever positive, flow out is ever negative. So this is the resistor here. This one is the flow in. And this one is the flow out. So flow in ever positive and flow out is ever negative. And because of this one, if you want to find a supply voltage to the Vs, to the Vs is the low voltage you can calculate 4 plus 20. You got the 24 volt. The next one will be that we want to convert the source conversion. So what source conversion means that voltage source and the current source can be converted. Okay, so voltage source is like this. every battery got the voltage and also battery got the internal resistance. So the battery, so you can convert, represent. So this is called the battery voltage E. So this is an R1. So this is the terminal. So this is the E is equal to I multiply R1. The current is I, so this is E is equal to I multiply R1. So this is the voltage source. The voltage source means battery voltage for the E, transformator for E, and the internal resistance R1. So this is E and R1 in series. This is for the voltage source. And current source means that the current and the resistance are connected in parallel. So this is for the current. The current I you can calculate E divided by R1, and this resistance R1 is parallel. So this is for the current source. So if you see the voltage source, you can transfer to current source. If you find the current source, you can change to the voltage source. So we can change interchange the current source and voltage source alternatively. So this is for the source conversion. Voltage source. This voltage source is the voltage is a 6 volt. Resistance are so resistance is 2 ohm to current source. So the formula is I is equal to E power R. So this 6 volt divided by 2, so you got the current. And this resistance is connected in parallel. So that will be the current source. So that means that you can change the voltage E is a 6 volt. E by RS. So this 6 by the 2 you get 3 ampere. It flow here. So this one in connected in parallel. RS equal to 2 ohm. And this is RS equal to 4 ohm. So we call it flow like this. So we also need to find the current passing through the 4 ohm load. So you have to find the current IS. So how to find the current? So you have to use the current divider theorem. So the total current is 3 ampere. So this 3 ampere multiplied with RS and divided by RS plus RS. So you got the IS. So IS you can calculate. I total multiply RS divided by RS plus RS. So the I total is 3 ampere, RS is 2, RS is 2, RS is 4. So this is a 12 divided by 6, you got a 2 ampere. Current is 4. So in this problem, this is the opposite to the previous one. Previous one is a voltage source given, so you find the current. Now is the current given, so you have to find the voltage. So today is 9 milliampere current is passing through the resistance. So how to find the voltage? Voltage means that we multiply with the current and resistance. So then voltage. So in this case, when you cover the thing means that if the current direction is outward, voltage so will be this is positive, this is negative. When the current direction is downward, the voltage will be this is negative, this is positive. So this is the voltage and the current direction. Current direction outward, the top will be the positive and bottom will be the negative. When the current direction downward, top will be negative and the bottom will be the positive. So by this way you can interchange the direction, polarity of the voltage and the current source. So now you see that the current direction is downward. So the voltage will be the top will be the voltage source is this is the positive will be bottom and the negative will be top. So this is we change the voltage. So positive and negative. Okay, so 9 milliampere multiply 3 kilo ohm. So V is equal to 9 milliampere multiply 3 kilo ohm. So then you got the 27 volt. And then the resistor is connected in the series. So connected in series with the resistor is now connected in series with the voltage source. So resistor RS is series. 3 kilo ohm. And then this one is the 14 in series with the RS. RS is 6 kilo ohm. Okay, now we can find this one here. This is one letter here. It's a negative positive. So 27 volt. So RS equal to 3 kilo ohm. So this is RF is equal to 6 kilo ohm. Let me call that. 27 means 9 milliampere minus 3 kilo ohm. So this is a 9 millisign 9 into 10 power minus 3 into the 10 power 3. So then you got the 27. Yes, 9 milliampere. Yes. And so this we call like this. And also the load current for the ESO means that we have to find the total load current. So load current is this is at the base. This will be so this one we got. So this is for the we find that so load current is also the same as 9 milliampere. Load current is equal to 9 milliampere. Because this 9 milliampere current flow to load. Okay, current source in parallel means that sometimes our currents are really going like this. This is the current I1. I1 go to this direction. And this is I2 go to this direction. And I3 go to this direction. So they are combined at that point here. So where to find the I2 then? So in this case, you see that the current direction flow in and flow out. At the point, flow in current is ever positive and the flow out current is negative. So this is the point here. This is flow in. So flow in current will be positive. And from here, this is flow out. So flow out is a negative. So then you see the current direction. I1 current is this is a point. So this is the point. So I1 current is flow in, I2 flow out, I3 also flow in. So then you can calculate that current ID here. ID is equal to I1 flow in. So this is positive I1. I2 is a flow out, negative I2. I3 flow in, positive I2. Positive I3. So by this way you can find the current to the current. And similarly, voltage source. The voltage source in a series. So in this case, instead of that you are representing all the three current source, the whole current source can be represented by only 50. ID, so we can represent. Instead of representing all three current source, we can represent by a single current source. Single current source ID you can calculate I1 minus I2 plus I3. So this is for the current source in the parallel. And similarly, we can also calculate the voltage source in the series. So this is the voltage source. V1, and this is V2, and the V3. So this is positive, negative, negative, positive, positive, negative. So you can have to take this any direction. If you take this direction positive, this one will be the negative. If this direction is a negative, this one will be the positive. So that you can put that there. So if there's a V1, this direction positive means that you have to find a total voltage VT. So VT you can calculate. So positive V1. So you come from here. You are working on the network. You are working on the network like this. So this right here. You're working so that you see the positive V1. And then you see the negative and you see the positive. And because of this one, you have to write positive V1 plus and negative V2 plus positive V3. So that will be the BD is equal to B1 minus B2 plus B3. So when you working on the network, so firstly you see the positive side, so positive B1, and then you see the negative side, and then you see the positive. So this is a positive B1 minus B2 plus B3. Then you got the BD. So instead of all the three boleto, you can represent by a single boleto, BD. So BD is represented as B1 minus B2 plus B3. So convert their own to a two current source. So 6 ampere current is going outward and a 10 ampere current is going downward. So in this case, going downward current is greater than the going outward. So to find the total current, so that will be 10 minus 6. 10 minus 6 and direction will be the downward. So that this is that you can combine it two current source to one. So that will be total current will be the total current, so you can calculate 10 minus 6, so 4 ampere. That will be going downward. Okay, then we have two resistors. Resistor R1 is 3 ohm. And resistor R2 is a 6 ohm. So we call it R1 3 ohm and the R2 6 ohm. So two resistors are now connected in parallel. By the combination, we can use the formula. This means that is a resistor R1 and the resistor R2 are connected in parallel. R2 that you can calculate R1 R2 divided by R1 plus R2. The formula you can write is 1 by RT is equal to 1 by R1 plus 1 by R2. So this is 1 by RT equal to, so this is a R1 plus R2, R1 R2. Then you go like this. So this is for the resistor connected in parallel. And similarly, R1 is 3 ohm, R2 is 6 ohm. So you can calculate the RT. So RT you can calculate 3 multiplied 6 divided by 3 plus 6. So 18 divided by 9, you call it 2 ohm. Because of this one, you can then represent total equivalent current is a 4 ampere going downward, and total RT is a 2 ohm. So that way you say the current will be 4 ampere, and total RT is a 2 ohm. So this is the equivalent circuit. That means that this is a closed network. So this voltage is the supply voltage E. The resistor R1 voltage will be the V1. Resistor R2 voltage will be the V2. So we have to write the voltage equation. So this equation, this is the closed network. Closed network means that this is not open, so all are supplied by the battery. The resistor R1, the voltage across is a V1. Resistor R2, voltage is a V2. The current flowing here is a I. The common current flowing is I. Okay, you have to put the positive and negative. So battery, the longer terminal represent the positive, shorter terminal represent negative. So when the current flow here, this one will be the flow in white, so positive, this one will be the flow of white, so it's negative. For the resistor R1, this one is the white is the flow in white, is a positive, white is the flow in white negative. And similarly, resistor R2, the current flow in white is a C, white is a positive, white is a negative. So that by the way you can put this up ABCD. After that you have to find the current. Current means that if you are working along in this circuit, you are working in this direction. Okay, what will you do? So you will firstly see the negative. Okay, so this is negative point. So because of negative, you have to put a negative. The voltage value is E. So this is a negative E. Plus. And then you go to the here. Here you put the positive point. So you just put the positive. And current I resistor R1. So this is for the positive V1 plus you go here you see a positive V2 is equal to 0. So this is for the equation of the current law. The two data voltage. So this will become minus E the V1 plus V2 equal to 0. And V1 is the resistance is R1, current is I. So I multiply R1 is a V1. And similarly, the V2, the current is I, resistance is R2. So I multiply R2 is V2. That will be that E IR1 plus IR2 is equal to 0. So this is about the approach to the basis of principle to solve the current closed network. Okay, the next one we use the application of the determinant to solve the equation. We can calculate. So how to do that? To use multiply this and this one negative. So M1 B2 negative M2 A2 divided by, so you multiply this way, you multiply this way. So this is a A1 B2 negative B1 A2. So this is solution for the I1. So I1 formula we can calculate like this, and also that we can also calculate for the I2. So I2 formula is, so that will be the determinant A1, B1, N1, N2. So that will be the denominator will be the A1, A2, B1, B2. So that is also similar to the A1, M2, this right here. Minus D1, B, N1. And this is the A1, B2 minus B1, A2. So this is for the determinant equation. So this is for the two